Hello, and welcome to part 2 of the uni-specific GSA introduction tutorial videos. Today we'll be talking about the sections and elements, how to create sections and section properties, how to apply them to the elements, and how to apply those elements to the structure itself. So to begin with, we want our elements to consist of certain materials. So we go to properties, and no, we don't. We go to, where do we go to? Yes, so we need to produce first a material grade. So materials, material grades, we're going to go just for a steel structure for now. So double click on that. So we can now apply the very specific values for all of our steel. So how dense it is, what its Poisson's ratio is, the elastic modulus, its maximum strength, and you could figure out all this yourself, or if you click on this first section here, or just any of these, and right click, go down to Wizard. In GSA, Wizard is essentially a shortcut version for predefined values. So click on Wizard, and it will just give you some standard grades. So if you go to Design Codes, and yep, so default steel. So here you can decide what steel grade you want to use. So say we want to use S355. Click on that right there. Click OK, and that should. Yep. Oh yeah, sorry, no. Up here. So standard grade S355. OK, and that will automatically input all the values for strength 355 steel into all of these. Click OK, and we now have a steel material with all the correct values inputted. Next, you want to go to your section library. You want to create a section. So same again. You want to use the wizard. So we've created a grade. We're going to be using that grade. Then you have the profile. That is simply, if you have an I-beam, you'd see an eye here. If you had a circular beam, you'd see a hollowed out circle here. This is the cut section of the steel beam you're using. So you want to go over to profile, then to catalog. You can create your own beams. So these are all your different types of beams, and then say you want an eye section. Click next. You can now determine the actual eye section if you want to make a unique beam type. However, we want to use the catalog, as the catalog allows us to use real world examples of beams. So we go for the British catalog. What type? Parallel flange. Nope, we want universal beams. There we go. And then here you have all your universal beams, which would be very common if you're in a British university, or universal column. And if you're somewhere else in the world, then you'll be able to see all the different types there. So we're going to go with a universal beam and say 356 times 127 times 33 universal beam. So that will then put all of these properties. Normally you'd have to apply these all manually. However, because we've used the catalog library, they can automatically be inputted for us. Click Finish, and now we have that beam profile set up for us. Click OK, and we now have a section. So we have a grade of steel, we have a section that steel is going to be applied to, and now we can create the elements that consist of that. So for an element, very simple. So what type of element it is? Is it a beam? Is it a bar? Is it a spring? Is it a here it says quad for quad A triangle. This is simply plate values. So quad 4 is a plate with 4 coordinates, so a square, a rectangle, a rhombus. Quad 8 is an octagon. Triangle is a triangle. We don't have to worry about that right now. You just need to worry about your beams. What property? So properties is simply the number that you put in here is this number on this side here. So we've created property number 1, which is right here. So for our elements, we want property number 1. Now, if you didn't have a property here, this would come up as red because there wouldn't be a property 1 in the properties tab, and it wouldn't like that. That's okay. Topology. So topology is essentially what node does the beam start at and what node does the beam end at. So right now we're saying that the beam starts at node 0 and ends at node 0, but we don't have a node 0, we have a node 1 to 4. So we want to go start at node 1, which is 0, 0, 0, and we want to go up. So we want to go up to 0, 0, 5, which is up here. So 0, 0, 5, that's node 4. So we want to start at node 1, and we want to go directly to node 4. Now that I've done that, now have a beam element starting at node 1, going up to node 4. And this, if you click over here, I know we said we wouldn't go over here, but this is just for display purposes, this far bit on the left. Click on section display, and that will give you the section display, and that is, as you can see, the section cut that we were given, that we gave into the section library. So go back to elements, same again. We want a beam. No, we don't want a beam. Property 1. Group you don't have to worry about just yet. Starting at 4 and going over to the other one that's up. So that's beam 3, so that's 505. So over to elements, starting at 4, going to 3. And another one, property number 1, group 1, starting at 3 and going to 2. And now that we've done all this, go over to the thing, and we can see we've created a frame here. Now, this is a bit confusing, especially when you have this on. I'm going to switch this off for now. When you have this on, it looks like these beams are not connected correctly. They're somehow merged together here. This isn't connected. It's all a bit confusing. Unless you specify otherwise, every node that has 2 beams or more coming to it, you can consider them all to be welded together. All axial bending stresses, they all transfer directly through it as if it was just one big element. If you want to create hinges or pin joints or anything like that, you're going to have to specify that. Otherwise, every single combination is automatically considered fixed together. All right, so yeah, that is how to create your elements and how to put them in your model. There you go.